So here is example number 4. So we've had questions that say expand completely. We have questions that say find a specific term. And the hardest questions are these ones that say find the term containing x to the 9 in the expansion of 3x squared, well, this will be a, 3x squared minus 2 over x to the power of 9. So these are the hardest ones because they don't tell you which term it is. How many terms are there going to be? There's going to be 10 terms. So worst case scenario, you find all 10 of them, and then you find out which one has x to 9 and circle that one because that's going to be the final answer. But that could take a while. So it would be nice if we could figure out a way to make this quicker. Okay? Now, since we can look at the exponent, and we can use the formula. So our formula says that any term is going to be 9 choose k, and k is 1 less than the term, but unfortunately we don't know what the term is. So we don't know what k is yet. So we'll just leave k in there for now. And we know that our a is 3x squared, and this will be 9 minus k. And we know that our b is negative 2 over x to the k. So in these questions, we can write things out, but we don't know k. We are going to find k, and we can find k either algebraically, or it actually isn't too hard to find it with guess and check. I'll show you the algebraically first, and then we'll talk about how you could figure this out with guess and check. Now, we want the term that contains an x to the 9. We don't know what the number in front of it is. In fact, we don't care right now what the number in front of it is. We are going to ignore everything that affects the number in front and just think about the x to the 9. So if I know it has to have an x to the 9, my 9 choose k, do you know that that's going to be a number? That's going to be a number that affects the number in front. I'm going to ignore it. This 3, it's going to be a number when it gets to whatever power this is. 3 to that power is going to be a number. I'm going to ignore it. X squared to the 9 minus k, can you see that that's going to be x to the 18 minus 2k when you apply your power rule for exponents? Okay? And over here, if we ignore the numbers, I'm just going to put a 1 on top. How many x's are going to be on the bottom? X to the k. Which could be x to the negative k. How do you work with your exponent laws? What does this mean when I have x to the 18 minus 2k times by a 1 over x to the k? Well, we would add them if we're multiplying with the same base, but then I'd have to first change this to x to the minus k. Or you could say this is the same as this, right? And what do we do when we divide with the same base? We subtract our exponents. So now I'm going to get x to the 18 minus 2k minus k. Now going back to our exponents and logs unit, how did we solve for something in the exponent if our bases are the same. We can just get rid of the x's now and say 9 has to equal 18 minus 3k. A little bit of math. I'll move the 3k to this side, subtract the 9 on this side, and divide. And I now know that k is 3, so I now know I have to find term 4. Because if k is 3, we're looking for term 4. And now that we know that k is 3, we can plug everything into our formula, go back, n is 9, so it's going to be 9, choose 3. A was 3x squared, and b was negative 2 over x. So we go to our calculator. 9 choose 3 is 84. Again, I'm going to do each of these separate. 3 to the power of 6 is 729. X to the 12. Negative 2 to the power 3 is negative 8 over x cubed. We can multiply all of our coefficients together. So 84 times 729 times a negative 8 and what happens when I have an x to the 12 divided by an x to the 3? I'll get x to the 9. So we know that it works. Term 4 is the one that has an x to the 9. This is the algebraic way of solving this one. What did we do? We're going to recap. Should I wait a second for you to write things down? Yes. So we'll recap what has all happened here. So we wanted to find a term with an x to the 9. We didn't know which term number it was, so we left k in our formula and wrote it out. 9 choose k, 3x squared to the 9 minus k, negative 2 over x to the k. We wanted to find k, and we knew the term had an x to the 9. We didn't know anything about this number in front. We found that later, but at the beginning we know nothing about that number in front. So what we do is we temporarily forget about all the coefficients, or we temporarily forget about everything that affects the number in front, because our only clue is this x to the 9. So the 9 choose k, if k was a number, would be a number in front. Your 3 inside the brackets will affect the number in front. This negative 2 inside that bracket will affect the number in front. In other words, we ignore everything but the x's. So here I have an x squared. What happens when that x squared is to the power 9 minus k? I get x to the 18 minus 2k. What happens when this x on the bottom is to the power k? I'll get an x to the k on the bottom. And that's why I wrote a 1 on top. I was just ignoring the negative 2. You could have, if you wanted to, you could have written negative 2 to the k on the top, and it wouldn't be wrong at this point, and you could ignore it later. Okay? So what we are doing in these steps is we are ignoring all of the coefficients. And once you've done that, the rest was using your exponent laws and your algebra skills with exponents to solve for k. That being said, a lot of people can just look at this and figure out k. For example, other than, we know that k was 3. So pick a number other than 3. Say you just picked a random number to start with, 5. How many x's would I have on the top if k was 5? Well, this would be a 4, right? X squared to the 4 would give me 8 x's on the top. And if k was 5, that would give me 5 x's on the bottom. When that simplifies, I would get an x to the 3, which is obviously not big enough because I need an x to the 9. And so a lot of people use this strategy. They start with a value and they say, oh, I need more numbers on top, less numbers on the bottom, so I should make k smaller. And then they might try 4 or might try 3. And usually it takes 2 or 3 times and they'll get it. Sometimes you get lucky and guess the right one right away. That's another strategy. Just try a couple of values. There's only 10 values because there's only 10 terms, so it's not like there's a lot of guessing and checking to do. Although sometimes, and I have seen this on final exams, they do say find the term algebraically. Then we need the work that we've shown. But if they don't say that and they allow you to just say find the term, often you can see what k is quite quickly just by putting in a couple of values and doing some mental math and thinking how many x's are on the top, how many x's are on the bottom, what's going to happen. Sometimes they only have x's in one place, and then it's really easy to figure out which is the one that's needed. And a third strategy that's sometimes used in these questions is by starting with the first term. When k is 0, how many x's would there be? Well, can you see that when k is 0, you'd have 18 of them? Because this would be a 9, so there'd be 18 on top and none on the bottom. Then when k is 1, can you see that you would have 16 on the top and 1 on the bottom, giving you 15. When k is 2, you'll have 14 on the top, 2 on the bottom, giving you 12. And there will always be a pattern. Do you see the pattern in the exponents? It's going down by 3. You could keep going down by 3 to get all of the x's for all of the exponents. So this is term 1, term 2, term 3, term 4. That's the one we're looking for. And use that to help you figure out which term it is. Either method that you use, once you find out what term it is, you still have to find term 4. And this last part would be identical no matter what strategy you used to find k. These are the hardest questions because you have to find k first, and then you still have to find, like the last part of this question is identical to example 2. So, or sorry, example 3, finding a specific term. So these are definitely the hardest ones, and where they make things more difficult is sometimes they'll ask questions like, can you find the constant term? What does constant term mean? No x's. So which one is it going to be in this one? Term 4, 5, 6, 7. Term 7 would have been the constant term in this one, because that's where all of your x's would have canceled out. So to start off next class, I'll do one of those constant ones. Question you can do from the homework like this is number 9.